just welcome you all here tonight and thank you for joining us to our first Maria Mitchell Observatory virtual open night. I'm Regina Jorgensen. I'm the Director of Astronomy here at the Maria Mitchell Association, and I'm really excited to be able to help host this night. And hopefully we'll have fun. I want to put out a little bit of a warning right at the start. This is the first time we're trying this, so we hope that it goes smoothly, but we also know that you will all hopefully please bear with us in case we encounter any technical difficulties or anything like that. And first of all, as it says on our slide, I'd just like to note that we do strongly encourage you all to please ask questions. Usually when we do these open nights at the observatory, of course, they're in person, and it's very much a conversation between us and our guests, and we really love to answer questions that you might have. And so I'd encourage you to please use the Q&A function down at the bottom of your screen to ask questions, and I'll be monitoring that throughout the night, and I will jump in with questions as appropriate. We'll kind of try to mix them in while we're doing the observing and the discussion. And then if you can't find the Q&A, you're also welcome to put them in chat. And then we also do have the ability to unmute you. If you would like to raise your hand, we can actually unmute you. And I'll just say, as a word of just to note, sometimes it takes a few seconds for the unmute to actually go through, so just give it a second. And one note to everyone, we will be recording tonight's event. So this will be available later on our YouTube channel in case you have to take off early or you'd like to share it with your friends. We will make this available online. And I'd also like to say we're very happy to be able to offer this event tonight for free. But of course, Maria Mitchell Association always appreciates donations, and you're more than welcome to visit our website. And I think we're going to put a direct link in the chat in case you would like to make any kind of donation to the Maria Mitchell Association. And with that, I think we'll go to the first slide here, and I'll explain a little bit about how it's going to work. We have some live views from the telescope. We're going to be focusing on bright objects tonight, so the 3 planets that are visible in the sky. And we're going to move, we're basically going to be observing a planet and then having a few slides of discussion about the planet. And again, we can also interact and answer your questions as you have them. And then we'll just go from, because it'll take a few minutes to move from one planet to the other, while the telescope is actually moving, we'll be able to show some slides and have some discussion about the various planets that we're going to be looking at. So we thought we'd start off with a view of, actually, because you might be wondering, where are the planets? And normally when we're out at Loynes Observatory, we just show you. We look up in the sky and we point them out to you. And since we can't do that in this format, we thought we'd start with a view of the night sky. And this is taken from Stellarium, which is an online program that shows the night sky and objects in the sky and where they are. And you'll note that this view is looking towards the south, and it is for 9 p.m. Eastern Daylight Time in the Northern Hemisphere. So if you're on Nantucket or somewhere around the latitude of Nantucket and location of Nantucket, this would be approximately the view that you might see. And so what you can see right away, if you go out and you look to the south in your night sky, you'll see the brightest thing you'll see will be Jupiter, and then just off to its left will be Saturn. And then way over to the left, at this time, sort of just having risen in the eastern part of the sky, is Mars. And so those are the 3 planets that we're actually going to be looking at tonight. And with that, Georgia, is there anything you wanted to add about this slide?
No, I don't think so. Just get an idea of where the planets are if you want to go and look at them outside yourself.
Okay. Oh, and actually, I forgot to say, I'm so sorry. I should introduce the 2 people who are going to be helping out tonight as well, which is Georgia Stoller-McAllister, who's the MMO Research Fellow, and she will be doing some of the discussion and slideshow of the planets in between the observing. And then we have our intrepid observer, Saoirse Ryan, who you will see occasionally and will be operating the telescope tonight. So I'd like to first of all start by thanking both of them for helping to put all of this together. And so thank you both. And with that, I think, should we go to our first planet view, Saoirse?
Absolutely.
Should I stop sharing my
Yeah,
screen?
you may.
Okay,
Yeah.
you got it.
There we go. Can you guys see that?
We do see it. It's in the upper left corner, but we can
Yeah.
see it. I think. Shout out, audience, if you can't see it. So I would normally, if I was in an open night situation, I would ask the audience, what do you think we're looking at? And so I'm going to imagine you all answering. This is, of course, oh, there we go. That's nice. That was great. That's bigger view. So this is actually a live view of Saturn. This is what Saturn is looking like exactly right now. And of course, we're all located on Nantucket. So this is the current view from Nantucket, which is a pretty clear, nice night tonight. And I would just, when I first saw this, when we practiced this, I was extremely impressed. Obviously, Saturn is the planet with the rings. It's one of the larger planets in our solar system. It's a gas giant. And what really, really blew me away from seeing this is just how defined the rings are. And I'd like to point out the shadow of the planet on the ring that is behind. I don't know, Saoirse, can you move your cursor to that part just to sort of point it out? I do see a cursor on there. That's right. There you go. Yeah, exactly. So if you see the area where the little white arrow is right now, you might be able to notice there's kind of a black bit, and that's actually the shadow of the planet on the rings that are behind the planet. And I think it's really, really cool to see that. It very much adds to the three-dimensionality of the planet. Georgia, do you want to take over and talk about Saturn a little bit more? And I'll go ahead and check the Q&A. If you have any questions about Saturn or anything else, please feel free to put them in the Q&A box. And I do see someone with their hand raised. Bonnie, it looks like you have your hand raised. Would you like to ask a question? I'm going to allow you to talk. You might have to unmute yourself, Bonnie, or accept the unmuting.
So
Okay.
Is
Go ahead, Georgia.
Bonnie there? Oh, okay.
Yeah.
If you get it figured out, just jump in. I think someone else put a question in the Q&A that asked, what is the makeup of the rings? And so that's a great question. The rings are, they're made of rocks and ice and dust. And so some of the pieces in the rings actually are as small as like little grains of sand, and then other pieces are as big as mountains. So there's a wide range of size, but it's all generally like dust and ice in the rings. And there's actually, so the rings are divided into like sort of there's seven groups of rings. I guess they're all it's all like a bunch of smashed up bits of rock. So it's kind of hard to tell like how wide does a ring like counts as a whole ring by itself. So there's lots and lots of little ones, but they're kind of divided into 7 groups, and they're some of them are divided by actually moons or slightly bigger chunks of rock that are orbiting around and sort of making some of the separations between groups of rings. Let's see, there's other questions.
We have a question from Nolan, actually, who's watching, and Nolan wants to know, why are there rings around Saturn?
So I think that there are rings because there were like larger pieces of larger rocks that were orbiting around Saturn, and they got smashed, and all those like the smithereens are still drawn to the planet by its gravity, but they're not held together into a ball anymore, so they kind of spread out into a kind of a disk that's going around the outside. I don't know if you have anything to add to that, Regina.
Yeah, that was great, and you're actually touching on, we have a lot of ring questions. I'll mention 3 of them that are all relevant to the rings. Ellen's wondering, how old are the rings? Skip is wondering, do the rings change over time? And Robert is asking, what is the origin of the rings? And you've sort of touched on that a little bit.
On the origin, yeah, so it's from things getting smashed. So other planets actually also have rings, they just are fainter. Saturn has really nice big ones that you can see. And do they change over time? I'm not sure how, I don't know if they change significantly over time, like over how much time. But since it's lots of little rocks orbiting around, I'm sure they're changing all the time, on a small scale at least. Yeah, I'm not sure about on the large scale.
Yeah, I think that's right. And Georgia, I don't know I think you said this already, but they're not solid. Like you said, they're little rocks. In fact, if you had a spaceship, you could fly right through them. So while they look quite solid here in this image and in pictures you see, they are not at all. And you could actually fly right through them with a spaceship. Leah is wondering why the image skips around. Is it the telescope refreshing or the movement of Saturn Earth? And I could just take that one really quickly. It's actually the telescope refreshing. So what we're seeing here is a special camera that's taking multiple images. In fact, I think you can even see in the control panel over on the right, you can see right now we're doing exposures of 140 milliseconds. So every 140 milliseconds, the camera is taking a picture, and that's what you're seeing. And so the jumping around, actually, that's the Earth's atmosphere primarily. So the telescope is tracking Saturn. So the telescope should be moving exactly with Saturn as it moves across the sky. So if there was no air, if there was no atmosphere, it would stay dead in the center. But because we have the atmosphere, we have all the air and the wind and whatnot, the atmosphere actually wiggles the light as it's coming through the atmosphere. And what that actually causes when we're seeing it is it causes the image to jump around. And this is actually a big difficulty for astronomers, because we want to see the light as it actually is and not as it is changed by our atmosphere. So this is actually a really good demonstration of one of the primary difficulties of being an astronomer and trying to take observations from the surface of the Earth, and why you actually want to put telescopes up into space, because you want to get outside of the Earth's atmosphere, which is causing this kind of image to look like it's jumping around. We had one more question on here about the rings, which is Robert's asking which other planets have rings. He couldn't hear what you had said.
Oh yeah, so other planets have rings. So for example, Jupiter also has rings. It's just you can't actually see them. Like you can see them so well for Saturn, but you need to be, I don't know, I guess you need a better telescope, or you need to be closer to see them for Jupiter, because they're much smaller. So it's much less material, less dust and ice that's making those rings. But since the rings are made up of like smashed up rocks, right, there can be anything that got smashed up around a planet then can turn into a ring around it. So Mars has 2 moons right now, but in a couple like million years, like 20 to 40 million years, it's predicted that one of them actually will get smashed up from the gravity. It's going to get torn apart by Mars's gravity, and then Mars will also have a ring, also smaller than Saturn's. But that's the idea of rings around planets.
Robert is asking if this is the new 24-inch telescope, and actually it is not. So because of COVID and kind of all of the restrictions that we're all living under, we have not really been able to use that facility much recently. This is actually Saoirse's own personal telescope that is located at her house in sort of mid-island location, and so it is I think it's about an 8-inch, is that right, Saoirse? Yeah. Yeah, so a little bit smaller than our 24-inch, but with, as you can see, really great optics. And Maya, my mom, is actually asking, why is Saturn the only one with a ring? Which I think you actually already answered, Georgia, that it is not. So there are other planets with rings. They're just not as obvious. Saturn kind of won in the ring game, and the other planets, while they have them, they're just kind of not as obvious. The cool one, did you mention, Georgia, Uranus? That it's like, I think it's Uranus is tipped on its side.
Okay.
So Uranus is a really fun planet. Most of the planets are kind of or spinning, and they're upright with respect to the plane of the solar system. But Uranus is really crazy. It's tipped almost completely on its side, so it orbits like this, and it actually has like a very, very skinny, very, very faint ring that you can see. So that's a great question.
And that kind of goes into actually one of the other questions about why are the particles in a disk shape? And that it, like Regina said, it has to do with how the planet's spinning, and the I'm not sure why it makes it so flat actually, but I think it just has to do with how the gravity's pulling all those particles together, and they're spinning around the planet, like they're orbiting around the planet in all kind of in the same direction, or at least together.
Yeah, I think there's also, you have angular momentum comes in. So it's the same kind of idea as if you've ever seen the person who's making pizza and they throw the pizza dough that starts as a round ball, they throw it up in the air and they spin it. Well, spinning things tend to flatten out. And that is a result of what's called angular momentum. And so that's actually the same kind of like basic physical principle as to why our solar system is sort of like a flat disk, why our galaxy is sort of like a flat disk. I'm simplifying a little bit because there is technically a bulge, but you oftentimes will see when you look at shapes of galaxies, you'll see spiral disk galaxies that kind of look like pancakes or frisbees, and that is basically for the same reason that the pizza person who spins the dough up in the air, it flattens out. So it's kind of the same basic physics going on. Okay, Anna Marie is asking, do the rings ever change their level, horizontal or vertical, etc.? So we kind of answered that one, I think. I mean, I don't think, that's actually a really good question. I don't know if in a particular planet, like for example, Saturn, the rings change much with respect to the planet, but what does change actually is our view of the rings. So right now, as you can see, we actually have, I should have mentioned this earlier, this is actually an ideal time to be observing Saturn. Because of the inclination right now, you can kind of see almost the whole ring structure. But in a year or two from now, that's not going to be true, and we're going to be viewing it much more edge on. So the inclination of the rings with respect to our view of them does change over time, over years. It won't change night to night, but it'll change over years as sort of the planets are all moving in the solar system in different ways. And so this is actually a really cool view of Saturn. If you go and look at old sky-in telescopes or look online, you can see different views of Saturn on different years where we're looking at the rings more edge-on or more inclined, which is what we're doing right now.
And if you happen to, if you are looking at it at the point when it's edge on to us, it can actually be really hard to see the rings at all because it's just like a line across you mostly can just see the middle part of the planet, the spherical part, and then the rings, if they're edge on, they're hard to see.
Leslie is actually asking which direction is this in our sky tonight, and this is to the south. So if you go outside and you look south, kind of about halfway up in the sky between the horizon and zenith, straight up overhead, you'll see Jupiter's the brightest thing that you can see, and Saturn is sort of off to its left.
And a little bit west, south and a little bit west.
Okay, John is asking if they'll be more flat and not as visible in a few years, how long until we can see them again? That's actually a really good question. I don't know off the top of my head when exactly, as I was saying that it's very inclined right now, and in a few years it'll be more edge on. I don't know off the top of my head what exactly, exactly when that's going to happen. I just know that it does change. Every summer that we look at Saturn, it looks a little bit different. I don't know if you happen to know that, Georgia.
I think I read, I know that Saturn has, orbits the sun every 29 Earth years. So because it's further away, it takes it longer to get all the way around. But I think that I read that it's twice every 29 years, it's edge on to us. That could be wrong. That's the number I have in my head.
Ellen is wondering what we can say about the moons of Saturn.
So Saturn has a lot of moons, actually. Saturn has, let's see, I think I already forgot. Is Saturn the one that's winning? I think so. Saturn, yeah. So Saturn has 82 confirmed moons, and maybe more. So this is actually an ongoing area of research. People keep finding more and more moons. So just 2 years ago, I think, was when someone found another 12 moons of Saturn, and it beat out Jupiter for the number of moons. And so there could still be plenty more moons out there that we just haven't found yet. The largest moon, so Saturn's largest moon, is called Titan. It's the second largest moon in the solar system, but it's the largest one that orbits Saturn. And it's interesting because it has a pretty thick atmosphere, made mostly of nitrogen. So it's sort of similar to Earth, except it doesn't have much oxygen, which would be helpful for life. But it does have an atmosphere.
We have a couple more questions about the moons. Elizabeth is, and I'll ask both of them, and then you can go ahead and answer if you want. Elizabeth is asking, how do you define a moon? And Anne is asking, how does one find the moons?
So these are both great questions. I don't know what the cutoff is for a moon, actually. I know it's something, it's got to be in the orbit around something bigger, but I'm not sure if there's anything beyond that defines a moon. I don't know if you know, Regina.
I think the definition is that it's orbiting a planet.
Orbiting a planet.
Yeah. But now with the newish field of exoplanet studies, where we're finding planets around other stars and whatnot, there are actually astronomers who are finding moons around those planets, or what they think may be evidence for moons. Of course, we don't see this directly because these are all very, very, very far away. So it's not that we're pointing a telescope and actually seeing them. They infer the existence of the moons based upon the orbits that they are models that they have to make in order to explain the orbits that they're actually seeing. So it's a little bit complicated, but where I wanted to go with this is that they actually have something now called moons, which are moons of moons, around other planets, around other stars. And they came up with a name called Moon, which I think is pretty funny. But so yeah, it kind of ties back into how do you actually define a moon question. And I think the primary definition is that it's orbiting a planet. However, then what happens if you have something that's orbiting a moon? What do you call it? You call it a moon.
Yeah. And I think there's been like recent discoveries of lots of potential moons around Jupiter also, and there's all kinds of sort of interesting things that I don't know much about, but interesting things about the moons. Some of the moons orbiting in one direction and some actually orbit in the other direction. So lots of moon research still to be done.
That moves into the question of how does one find moons, and why they're still discovering, like, why did we not already know about all the moons around Saturn and Jupiter? I mean, they're our next door neighbor planets in a way. And I think one of the difficulties is that a lot of these moons are actually quite tiny. We'll talk about, when we go to Jupiter, we'll talk about the Galilean moons, which are really, really big. And even Galileo saw them in his very, very simple basic telescope. But, you know, there's so many other moons there that are just so tiny. They're really, really, really hard to see. And so you need very large telescopes, and you need very special instruments that can take long exposures and look for tiny things, which means that they're not very bright. And so basically that's what is being done right now. We were just talking about this earlier today because we were trying to get the most updated count on the moons of Saturn and Jupiter. About one of the people who leads in this field, his name is Scott Shepard, and he uses the Magellan telescopes, which are located in Chile, which are really, really, really large telescopes, to actually very, very carefully, what he basically does is he takes pictures in the area of Jupiter or Saturn, and then he takes a picture a little bit later and he looks for anything that was moving. And so if you see some, you know, the stars will be fixed, they won't move over time, but moons will, because they're moving relatively quickly. And so if you take a picture at, you know, the beginning of the hour, and then you take a picture at the end of the hour, and you actually subtract those, what'll pop out is something that has moved in that time frame. And so that's kind of one way of finding these moons. Skip is wondering if the moons are inside or outside of the rings.
I don't know about all of them. I think both things, perhaps. I know that there are some moons that sort of orbit within the rings, even like there are two. I know there are two moons at least that are called Shepard moons because they're actually keeping one of those rings in its place by orbiting around near it. So I think they're kind of spread out.
And Malcolm's actually asking a great question. How can moons orbit in different directions? Which I can answer if you want, Georgia. Do you want me to?
Yes, you should answer that one.
Well, really, the answer is we don't really know. And this is actually kind of a really cool mystery. So, and again, this is a lot of Scott Shepard's work, that he actually finds moons that are orbiting counter to the majority of the moons or the rotation of the planet. And so he and other people are trying to figure out how you would get this happening. One thought is there could have been a collision with, say, either ring particles or an incoming asteroid that hit something and actually imparted, motion in the opposite direction. And that could be one way you could explain this. because it doesn't seem like it would come just from your natural, you know, planet formation. Everything's kind of orbiting in the same direction. And so you definitely would need to invoke something coming in from the outside with a different motion in order to explain moons going in the opposite direction. Good question. Let's see. We have a couple more questions, and then probably we can, we actually do have a couple slides that we can show while we move to our, I'm just looking at the time, and maybe we can take these questions while we move to the next target. Saoirse, do you wanna, should we move on to Jupiter? And while you're doing that, we can show our slides?
Absolutely, that sounds great.
Okay, thank you so much. So everybody say goodbye to Jupiter for now. Thank you so much for this view.
Saturn.
I'm sorry, to Saturn. Thanks.
So, right, I'm stealing your screen share, Saoirse.
While you're bringing that up, I'll read. We have two more questions in the Q&A right now we haven't answered yet. Elizabeth is wondering what distinguishes the floating debris in the rings from a moon. Oh, that's a really good question. Right. So that kind of gets at what we were talking about earlier, the definition of a moon. And we'll come back to that. And then Ellen is wondering, does Saturn have storms like Jupiter?
So Saturn does have storms. Yes, Saturn does have storms like Jupiter. It actually has these pretty big cyclone type storms at the poles, and a lot of those stripes that you can see on Saturn here. If I go back one, you can see them a little better on this image. They're not storms necessarily, but they're different levels of like clouds of different materials that are spinning around on the outside of the planet. But yes, Saturn does have storms like Jupiter. Actually, I think Saturn has some of the highest winds on a planet in the solar system. And then which one?
Let's see. Going back to Elizabeth's question about the floating debris versus the moons, I suppose that it would have to do, you know, with the fact that, you know, the floating debris is all relatively small compared to the moon. So it's, you know, sort of, it's actually can be quite small, in fact, like small little ice cubes, basically. And, you know, the moons are much bigger than that. Although they are small relative to Saturn, so they're difficult for us to actually find. They are much bigger than the particles. I'm realizing as I'm saying this that somebody actually asked a question we didn't answer, which is how thick are the rings? And this is a really fun question. I don't know the actual number, but I do know a really good and real analogy, which is that the rings of Saturn are actually the thinnest structure in the solar system. Let me put it that way, that we know about. And if you shrunk them down to the size of a football field, the thickness of the rings would be about the thickness of a sheet of paper. So if you can imagine a sheet of paper that's the size of a football field, that gives you an idea of how thick the rings are in comparison to how big they are. So they're actually really thin. The only reason we see them so well right now actually is, as Georgia pointed out, because they happen to be very inclined with our viewpoint right now. And they're also really reflective, so they reflect a lot of the light.
Someone else had a question about which direction they rotate. I don't know that actually. Do you know, Regina? Sort of relative, which way you're looking at it.
Good question. I think it's the same direction as the planet, but looking at like this picture, for example, that you're showing here, I'm not actually sure. I believe it should all be, though, in the same, it should all be with respect to the same direction that the planet's orbiting with respect to the sun.
Yeah, I think so. And then, so this is a pretty awesome picture. This was just taken last year, actually, with the Hubble telescope, and you can see how like there's lots of layers of rings even, and then this is a break in the ring, so like a gap, and it's called the Cassini Division, named after astronomer Cassini. And then there's other different layers. So you can see there's sort of some breaks in here and another one further out along the edge. So this is, I think, I'm not sure which one is like exactly where they decide the dividing lines are between rings, but I know that they are grouped into seven groups of rings. And then, oh yeah, and then this image was taken in 1979 from the Pioneer 11 spacecraft, which was, I think, the first spacecraft launched that went into orbit around Saturn, which is also a pretty impressive picture.
Georgia, do you want to show your animation? Oh, unless we have,
Sure.
do we have Jupiter ready, Saoirse?
We do.
Oh, okay. Maybe we should actually, just in light of the time, maybe we should go ahead and take a look at Jupiter, and we can talk about Jupiter for a little bit, and we can always come back if there's time to talk about Saturn more.
Yeah, sounds good. You can go ahead and steal the screen sharing whenever you're ready, Saoirse.
Oh, come back.
Good.
It's trying to escape.
So next up will be Jupiter, which is, as most of you probably know, the largest planet in our solar system. It is also a gas giant, which means that it's primarily gaseous. It does not have, it may have at the very, very center a solid core, but we don't even know that yet for sure. So, you know, if you were to try to land a spacecraft on Jupiter, well, it would be difficult because there's no solid surface for your spacecraft to actually land on.
Sorry, it seems to have gone out of the field of view. I'm gonna have to go back. Sorry.
Okay, that's okay.
No
We can
worries.
go to some Jupiter slides while we try to get Jupiter back in the telescope.
Yeah.
Right back.
So here's some cool images of Jupiter. So this one's also at the Hubble telescope. You can see all the different layers and not rings on the outside. It does have a ring, but you can't see it. But these sort of different swirling layers of the planet. And then this is the Great Red Spot. So the Great Red Spot is a ginormous storm. It's bigger than Earth. So Earth would fit inside here. Jupiter is the largest planet in our solar system. It's actually the mass, it has twice the mass of all the other planets combined. And so then if you think about it that way, you could fit 11 Earths across the center of it. So then it kind of puts the largeness of this storm into context. And it's been going for over 300 years. So it was observed in the 1600s also, but it does seem to be, apparently it's getting slightly smaller over time. And there's always other storms happening also. And then this image, which I think is super cool, is actually of the pole, the pole of Jupiter. And it was taken by a NASA mission, a satellite that's orbiting Jupiter. It's called Juno. And this image was taken in infrared, so it's taken in wavelengths that you can't see with just your eyes, but it's showing temperature actually, and the lighter colors are thinner clouds, and they're really cold, so about 9 degrees Fahrenheit. But then the darker spots are even colder. Those are the thickest clouds, and they're a negative 180 degrees Fahrenheit. But this is a big cyclone at the pole, and then it has these little other cyclones whirling around the outside of it.
That's great. You've actually answered Skip's question, which was, what do the various colors represent? Oh, and in case you were, the optical image, which is the one on the left, the Hubble one, those colors, that's mostly what's called a true color image. And here the different colors are being created by different types of gases that are actually make up the planet. And in fact, fun fact about Jupiter, it's a gas giant, as I mentioned, and so it's not solid, and it's actually doing something called differential rotation, which means that different parts of the planet are rotating at slightly different speeds, and you can kind of see that that's what's creating those bands. Jupiter has really famous bands, or as one person once described them as racing stripes. I really liked that a lot, and that's actually a result of this differential rotation of the planet. We have a couple more questions, but I noticed Saoirse's back. Do we have Jupiter in the telescope? Should we switch to the view?
Sure.
Okay. And we'll just keep talking while we do that. Ellen actually asked a great question. Most objects in the solar system are named after men. Are we trying to fix this imbalance? Well, there's Venus, I suppose, but unfortunately, or fortunately, however you look at it, most of the planets were obviously have had names, for a really, really long time. In fact, they're all Roman gods. Oh, there it is. Nice. And so now we're gonna see it jump around a little bit because of the atmosphere. Cool. And I don't know if that is the red spot down on the kind of lower right side or not. It could be. You can actually see some of the bands, the stripes that we were talking about. Oh yeah, and I think that is the red spot, actually. You guys can tell me if you agree. Yeah. Which is pretty cool. So you don't always necessarily see it. Sometimes it's on the opposite side of the planet, right? So we don't necessarily know any given time that we're observing it if we're going to be able to see the red spot or not. Very cool. Back to the planet naming question. I mean, at this point, the planet names are fixed. So, and I'll just mention as far as naming of things, astronomical things, nowadays, things are all named by what's called the International Astronomical Union, or the IAU, which is a body of professional astronomers around the world. And they have various conventions for naming things. In fact, I think at this point, the only things that are ever named after people anymore are actually comets. Maybe there's something else, Georgia, or Saoirse, do either of you know? I think it's just comets at this point, and everything else
on the moon.
And craters on the moon.
I think
and everything else that's
potentially are
asteroids. Well. Okay. Everything else that's discovered, like galaxies and quasars and all of that, has a very kind of boring naming convention, which has to do with the object's location on the sky. Basically, it's kind of like latitude and longitude. You can think of it that way. So an address, essentially, so that when we talk as astronomers, we say, I'm looking at this object and here's its latitude and longitude, so someone else can go and know exactly what object I'm talking about. So we typically don't name things after people anymore, with those few exceptions that we were talking about.
Well, there also are some, sometimes the newly discovered moons get names. So I know that when a bunch of, sorry, I can't remember if it was Jupiter's or Saturn's moons, but when there was a whole group of new moons that were found, they were getting names, and they were naming them in, like, depending on, they were sort of categorized in different groups. I know some of them were being named after Inuit mythology, or sort of like characters and stories. Some of them were Gaelic. Another group was after Gaelic. Another group was after Norse mythology. So there are still names. I'm not quite sure how you decide on those, but there's a theme.
Malcolm's asking, why is the spot still going? One would think that a storm would eventually burn out.
So I think part of the reason that the storms go on for so long is that because it's a gas giant, there's no land to sort of break up storms. There's nothing for them to crash into. And so they have all this momentum going. They just get to keep going and going because there's nothing to stop them. That's my understanding. I'm not sure why this one is. I'm not sure if other storms go as long as this Great Red Spot one, and they're just maybe less spectacular to look at, or if this one is special in that way. I don't know if you know, Regina.
I think you got it, Georgia. I think your answer is great, and it's so big. So I think that's one of the main other reasons. And Anne was actually asking the exact same question. Skip is wondering, what are the gases? It's primarily hydrogen and helium. And Robert is saying, so Jupiter rotates on its axis, how fast, and the length of a Jupiter's year? Yes, Georgia, do you want to take those numbers?
Yeah, so Jupiter rotates on its axis, and it actually rotates super fast. It has the shortest day of any of the planets in the solar system. It only takes 10 hours for it to spin around. So it's kind of crazy that it's this ginormous planet, and then it can spin around so fast, which I think has something to do with the storms as well. And then what was the other question? How fast? The length of a year. So it takes 12 years, I think, 12 years to orbit the sun. Yeah. So because it's further away, it takes longer to get all the way around. But Saturn's was 29 years because it's even further away.
And Anne is actually asking, is Jupiter the only planet that's comprised of gases versus more solid materials? And the answer to that is no. The inner planets, so Mercury, Venus, Earth, Mars, are what's called the rocky planets, which are solid pieces of rock. And then all of the outer planets, Jupiter, Saturn, Uranus, and Neptune, are what are called gas giants. And they are primarily made up of gas. And it just so happens that Jupiter is the biggest one of those.
And Jupiter, actually, because it's so big that those so like Regina said, it's mostly made up of hydrogen and helium, which is also mostly what the sun is made up of and what most stars are made out of. And if Jupiter were a bit bigger, it could have gotten hot enough to be a star itself, but it's not quite big enough for that.
Oh, are we looking at some moons there, Saoirse?
We are, yeah.
Cool.
We have Io right here.
Nice.
And then we have Europa a little further out.
Sweet. So these are two of the 4 Galilean moons that we were talking about earlier. Jupiter has, where did we decide on, 70 something moons, but it has 4 very big bright ones that Galileo saw in his very simple telescope, 400 years ago. And he actually was able to track the motions of these moons. And what's really cool is you can actually see them change their positions in the sky over a few hours. So if we were to come back in a couple hours, we'd see they wouldn't be exactly where we're seeing them now. And if you do that long enough, you can kind of figure out that they're orbiting around the planet in these circles or ellipses. And this was actually one of his main pieces of evidence to support his belief in what's called the heliocentric model of the solar system, which means that the sun is at the center. And in Galileo's time, the primary belief was that the Earth was at the center and that everything revolved around the Earth. But Galileo actually seeing here these moons that were orbiting around something else that was not the Earth, that was one of the main pieces of evidence to say, hey, actually the Earth is not the center. The sun is the center of the solar system. That's fantastic. Given the time, Saoirse, I'm wondering if we should maybe go ahead and try to check out Mars. And while you're moving on to Mars, we can keep talking about Jupiter a little bit. That's such a great view.
It's so cool. You can see the bands.
Yeah.
Stripes.
All right, yeah, that sounds great. I will go, I'll shift over to Mars.
Awesome, thank you so much. And in the meantime, please keep putting in your questions. Olivia is wondering if the latitude and longitude of objects change and how can you identify an object at a later time? So it depends a little bit on the object. For most of them, the answer is no, because they're so far away that any motion that they actually have is because they're so far away, that motion is not something that we'll actually see. And so for example, I look at quasars a lot and they're really far away. And basically we think of them as fixed objects. They're not technically fixed, but for all intents and purposes, they are. There are certain things though that do move in the sky. For example, the planets. If you go out, tonight and you go out next week, you're going to see that they're in slightly different positions if you go out and look at the same time each night. And so the planets, we've known for a long time, they obviously move, and you can see that, kind of night to night. But the farther away things are, in general, the less noticeable is what's called their proper motion. So their motion that we actually can see with respect to the background stars. So we kind of think of the background stars as being fixed. And so generally speaking, for certainly for things that are, for the most part, outside of our galaxy, we can refer to them as having a fixed latitude and longitude, a fixed position, and they will always be in that position year after year. So we'll always be able to find them again. Let's see, Ed is asking, do you know of any recent findings from the radio transmissions from Jupiter and the magnetosphere? And then similarly, well, maybe not. Ellen is wondering what we have learned from the Juno mission.
So the Juno mission, I think is I mean, it's still going, it's still out there, and it's getting more images both of the moons of Jupiter and also trying to see more of like kind of what's under the top layer of gases, looking into those, looking into the gases, I guess, of Jupiter a little more closely. I'm not familiar enough with it to know like what exactly has come out of it so far, but it's still out there. And then I'm not sure I understand the question about radio transmissions from Jupiter, but the magnetosphere, I know it has a very strong magnetic field.
Yes, that's right. I'll second that. if I can't remember exactly what it was, but if you could actually see of course you can't see the magnetic field with your eyes, but if you could see sort of how they do those onion diagrams of magnetic fields, and if you can kind of see how the strength of Jupiter's magnetic field is, it's very, very high. It's very, very strong. And it would be something like the size of the full moon or something like that on the sky. So the magnetic field strength goes way beyond the planet itself. So yeah, it is a pretty bright object in a lot of different wavelengths.
Should we go on to Mars or?
Yeah, why don't we go on to Mars? Feel free to keep asking questions about anything. We'll just go ahead and go on to Mars, since that's going to be the last planet that we'll look at tonight. Fun fact, maybe some of you have heard Mars right now. Actually, can you go to the opposition slide first? I'll just talk about that real quick. Mars right now is actually what's called at opposition. And that's best described by this diagram here, where you can see this is not to scale, but it just shows the relative positions of the Sun, the Earth, and Mars when it's at this thing that we call opposition. And basically what that means is that Mars is the closest to the Earth that it ever is during its orbit. And it's also, from our point of view, directly illuminated by the sun. So these things combined mean that this is a great time to actually observe Mars. So you're going to probably see lots of, it in the news, and lots of great, really cool photos. And hopefully we'll have a great image of it tonight that we'll see shortly. So this is a great time to be observing Mars. Okay, you can go ahead and go back, Georgia, to the previous one if you want to talk about that.
Sure. I found this image that I thought it was really cool because on one side we have the view from Mars looking at Earth, and then the other one is from Earth looking at Mars. And you can see they're kind of about the same size in the sky, which makes sense. The one on the left there looking from Mars, you can, if you look real closely, you can also see the moon. So the Earth is that brighter one, and then the moon is just a little bit below it. So it's kind of fun way to remember that the Earth also is a planet and looks like a planet if you're looking at it from somewhere else.
Very cool. Yeah, that is such a cool picture.
Yeah.
I really love that. Robert's asking, is the bright object in the morning in the southwest Venus? And I think the answer is yes. Georgia, is Venus up right now? It's so funny, because the planets always change kind of when they're up at night. If you don't think about it for a little while, you kind of have to go check. Usually though, with Venus, because it's closer to the sun than we are, when you see it in the sky, you either see it in the morning or in the evening, low in the sky. And so you'll either see it as you do is that right though? No, in the southwest, that's probably Mars. If you were to see it in the south, if you were to see it in the east, that would be Venus because it would be rising. Do you know, Georgia, do you want to double check me on this here? Is that right?
Yeah, I'm double checking. I think if you're looking like early in the morning, yes, so basically like at 6 in the morning, straight west, you can still see Mars. Okay. But Venus is off towards the east, sort of southeast.
So yeah, so Venus it will be in the west in the evening, so at sunset, or in the east in the morning, if that makes sense. So I think what you're seeing, Robert, in the southwest in the morning is actually Mars. So Mars is up right now in the night sky, but it's still kind of towards the east. And so I don't know if you remember from that picture we showed at the beginning, it's just risen a couple hours ago, which means it's going to be up all night. And so if you get up in the morning, you'll see it in the west just before it's set. Oh, there you go. Yeah, so you can see it kind of over on the eastern part of the sky, and it's going to make its big track across the sky and then set in the west. And right now, as you've helpfully observed, it's actually still visible in the morning. Oh, we have a bunch more questions. Let's see. John is wondering if Mars has moons. Oh, and then he said, never mind, he sees the answers in the fun facts. And, oh, okay, and Robert said, yes, his error, east in the morning. So east in the morning would be Venus.
It's Venus, yes.
And it's also very, very bright.
Yeah.
And we have a couple more questions, but I see Saoirse, so we might have Mars actually visible. So Saoirse, go ahead, and if you're ready, feel free to take over the screen. So just to answer, oh, cool.
That's so cool.
Cool. To answer John's question, Mars has 2 moons, Phobos and Deimos. I always kind of mess those up. Phobos and Deimos.
Phobos and Deimos.
Okay,
yeah.
thank you. And
for some reason, they're named after panic and fear in Latin. I'm not sure why.
Well, Mars is the god of war.
Okay.
Roman god of war, and so I think it kind of goes with that whole theme. And let me go down the questions here. Does Mars have a magnetic field? That's a very good question. I think that it does, but it's not a very strong one. Georgia, do you want to?
Yeah, I think also.
Okay.
I mean, the Earth also has a magnetic field, but it's not very strong. And Earth and Mars are pretty similar. Mars is a bit smaller, but I think it does have a magnetic field.
Mm-hmm. Oh, and Maya is actually asking, how often does opposition occur? Which is a really good question. Georgia, do you know?
I think the next time for Mars, I think it's going to be in another 2 years. I think the last one was in 2018. I don't remember the month. And then the next one will be in 2022 when it's in opposition again.
So something like every 2 years.
Yeah.
Okay. Because I guess that's
approximately.
I don't know. Because Earth takes 1 year and Mars is going around.
Mars is about the same. It has a slightly longer year.
Yeah.
But it's in the range of 300 to 400 days.
Great questions.
Yeah.
And maybe we've lost Mars.
Lost Mars. That's all right. We can go back to some other images. Let's see what else about Mars. So someone asked about a magnetic field, but Mars also has an atmosphere, which is interesting, but it's very thin and not like Earth's nice thick atmosphere, but it does have one. It also has the largest volcano in the solar system. So this volcano is named Olympus Mons. It's 3 times taller than Mount Everest, and it's also like super wide. So it's twice as wide as the state of Wisconsin. Yeah. There's some always great NASA pictures of Mars. This one on the top is actually of an ice-filled crater near the North Pole. And then the other one is looking at the sand of the surface and how the wind makes ripples. So since it has an atmosphere, it has wind. Like the moon, since the moon does not have an atmosphere, there's never any wind blowing around on the moon, but there is wind on Mars. And Mars has some giant dust storms from that wind. But I like this picture where you can see how it's like the wind comes up around this bigger rock and it makes all these cool patterns. And I guess we can go, I don't know, I think maybe we lost Mars in the telescope.
Yeah, do you want to go to your interactive?
Yeah, we can go to this model. Let me just stop sharing for a second.
And while you do that, I'll answer Olivia's question, which is a great question, which is there life on Mars? And that's a fantastic question, and actually a question of very, very active research right now in astronomy. So many people are trying to answer that question. Most likely there is not life right now on Mars, but there is a very high probability that there was life in the past. And there could still be, but of course it's not little green men, it's not human beings or anything like that. When I'm talking about life, I'm talking about microbial life, so bacteria, something like that. And in fact, there are actually some theories that life first developed on Mars, because in the early solar system, the conditions on Mars were much more like that of Earth. So it was, it probably had liquid water. So it was a bit warmer than it is now. And it might have had more of an atmosphere than it actually has now. And there are some theories that life actually might have developed first on Mars and traveled to Earth via an asteroid. And so it's kind of fun to think that we all actually might be Martians. That's kind of one theory. And so one very active area of research right now is trying to figure out if there, to find really definitive signs of past life on Mars. And in fact, in August this year, just a couple months ago, we launched our next rover. As you might remember, there's a couple rovers on Mars right now. We've just launched our next rover mission, and the main job of that mission is actually to try to look for this life. It's called Perseverance. It's supposed to touch down in February of next year. So that'll be really, really exciting. Let's see, we have more questions coming in. So yeah, to answer your question, we don't know. I think there's a pretty good chance that we will eventually find evidence of past life. And who knows about kind of active life right now. I don't think that there's as much evidence for that at this point. I see Saoirse's back. Saoirse, do you?
I do.
Let's see if we can get the view again. There we go. Cool. And I think you can even kind of see on the bottom the polar ice cap.
About there, little dot right there.
This is very, very cool. You can definitely see some of the features, some of the darker and the lighter features. Oh yeah, that's cool. I think one other thing to note is Mars is pretty low in the sky right now still, Saoirse, if I'm correct. So
I think it's near like 50 degrees.
Oh, okay.
It's fairly high up.
Okay. The lower things are in the sky, the more atmosphere you're looking through. And so the worse the view is going to be. So it's best if you're actually going out and observing yourself with your own telescope. The best time when you'll get the clearest view is when it's high in the sky, as high as it's going to be in the sky. That means you're actually looking through the least amount of atmosphere. If you're looking at something out on the horizon, you're looking through a lot more atmosphere, and so you're going to actually get a lot more of this wiggling, blurring activity. Ellen's wondering why there are so many missions to Mars and relatively few to Venus and Mercury. Great question. And actually, this has been really recently discussed a lot in the news and will change likely in the future here because of the very new exciting news of potential life actually in Venus, in the atmosphere of Venus. I don't know if you all heard about this, but a couple, 2 months ago or so, there was a paper that came out that had announced the discovery of something called phosphine gas in the atmosphere of Venus. And this is significant because this gas, we think, is only produced by life. And at least in that level that it was detected, in the amount that it was detected in the atmosphere of Venus. And the group who was actually made the discovery, in fact, they weren't expecting to find it. They were actually, they were wanting to find phosphine in exoplanets, because nowadays one of the things astronomers are trying to do is find potential signs of life on other planets, on exoplanets outside of our solar system. And so one of the ways you could do that is find gases like this phosphine that we think are produced only by life. And if you see that gas in the atmosphere, then you have a pretty good idea that there might be life there. And so this woman, it was actually a woman who was doing this, she was actually observing Venus in order to get a baseline measurement of what it looks like when you don't have phosphine, so that she could then compare, kind of like a control, to the actual observations in exoplanets. And lo and behold, actually she found this huge amount of phosphine gas in the atmosphere of Venus. And so it is not definitive proof that there is life on Venus, but it is very intriguing results. And so lots of people are now wondering about this observation, because historically, and actually what answers your question is Venus is similar to Earth in that it's the same size, similar size, has similar features, except it has undergone a runaway greenhouse effect, which means that the surface of the planet is something like 800 or 900 degrees Fahrenheit. It's just so hot that, life could not survive there. There's no water, it all gets evaporated away. And in fact, in the many dozens of times we've tried to send missions, and there was many missions by the Soviets when there was the Soviet Union. They tried to do this many times, and I think the only two that actually somewhat succeeded were Soviet missions. They landed and they had like a few seconds or maybe minutes to send back photos before the spacecrafts melted, basically, and were crushed by the extreme pressure that this really thick atmosphere of Venus has. So basically, it's hard. Mercury similarly is very hot. And so it's really difficult to send missions to these places because the conditions are so extreme that your spacecrafts basically melt. But nowadays, so there's this phosphine discovery. The idea there is that 30 miles up in the atmosphere of Venus, the conditions become much nicer. The temperature is much less extreme. And so the idea is that perhaps life in simple microbial form migrated up into the clouds of Venus and actually developed a way to sort of float and live about 30 miles up in the atmosphere. So it's kind of crazy sounding, and it's certainly, we have not proved this yet at all, but this is the idea that people have right now and are kind of exploring. And so, bottom line, what this means is now there probably will be more missions to Venus in the near future, because all of a sudden this has really renewed a lot of people's interest in the planet. Maya's asking, how could life have ended on Mars? A virus? Hopefully not. Well, that's also a very good question. Right now Mars is pretty cold. And so, I would say a combination of the planet cooling and the atmosphere, if it was thicker, the atmosphere dissipating and it becoming very dry. So there's no oceans on Mars. While we do think there might be liquid water underneath the surface, we don't see liquid water on the surface right now. And so the changing conditions, which were primarily getting cooler, caused the conditions on the surface, like for example, if there was liquid water in the past, that evaporated and disappeared, or it got kind of frozen and embedded under the surface. Georgia, I don't know if you have anything to add to all of that. I'm talking for a lot there.
No, I think you got it all. It is cool. You can see that ice, the polar caps.
Yeah.
Sometimes you can see it in this image, but it's a little bit jumpy.
Very cool. Well, we've gone a little bit past our time. Georgia, is there anything else you wanted to add about Mars that we haven't talked about yet?
I don't think so. I think we got most of it. Yeah, I'm so glad so many people could come. This has been really great.
Does anybody have any more questions? If you do, feel free to type them in. And if not, I will just start by saying thank you to all of you for coming tonight. Like I said, we will post the recording of tonight's event. So if you missed it or want to pass it on to your friends, feel free. And I want to give a really, really big thank you to Saoirse for really making this whole event happen, actually, and setting everything up so that we could have this viewing tonight. It's been really fantastic. It blew my mind when I first saw these images, so I'm
Me too.
super excited that we got to share them with everybody. So I hope you all enjoyed it. And I'd also really like to thank Georgia for putting together, all of the slides in the discussion tonight. Pamela's asking, when can one see the recording? We will, usually we get these posted the next day. So, and if you registered for tonight, you will get an email with a link to the recording, and it'll be on our, the Mariah Mitchell YouTube channel. So we'll send out a link to everyone who was registered tonight, and then you could also just find it on our YouTube channel. And it should be up tomorrow or the next day. Okay.
All right.
Awesome. Well, thank you all. And thank you all for coming. And thank you, Georgia. Thank you, Saoirse. And hopefully we'll get to do this again sometime soon.
Yeah. All right.
Thank you all.
Thank you all.
Bye-bye.